if we square both sides, remember, then down here we then have a negative a squared, which is a squared, and here you square the radical sign, then you get this one disappeared. So right hand side is basically like that. Okay. Yeah. Right hand side you do FOIL method. Okay. So you have a negative a squared minus plus cx. If you square that, you have to do FOIL method. So it's like that. And then this one, you FOIL that, you will get this. Because a squared times a squared, negative, you have a positive. Okay? And then negative a squared, cx. Cx, negative a squared, so you have a double that. And cx times cx is cx squared. Okay? And when you use a squared times this quantity, inside you have to FOIL it out first. X minus c squared is x squared minus 2xc plus c squared. And you have a y squared already there. So when you use a squared times this the red quantity, so you then have a squared, here's a squared, times x squared, so you have that, and a squared times negative 2xc, so you have negative 2a squared cx. And if you have a squared times c squared, so you have a squared c squared. And then a squared times y squared, you have a squared y squared. Again, you choose the square on both sides, square root disappeared. This negative a is going to be a squared, so that's why a squared appears everywhere. Okay, great. Now we are here. We are here. Left hand side, right hand side. Now let's look. What I like to do is down here, I like to use move c squared x squared on the right. So both sides minus c squared x squared. I also like to move this one both sides, you see I did is minus a squared c squared. So this one will be cancelled. Okay, and then these two I will put together, and these two will be cancelled because I did the same thing. And then those two are the same. If you add the same term on both sides, those two will disappear. So basically, those two will disappear. Okay? Those two disappeared, and I subtract this one. So this one goes to the right, this one goes to the left. But actually I did was minus a squared c squared. So you pull a squared out, then you will have a squared a to the fourth minus a squared c squared. You pull a squared out, you then have a squared minus c squared. Okay? this is left hand side, I moved to the right. Okay, again those two disappeared, and then when I subtract c squared x squared on both sides, this part disappeared. Okay, and then I will combine these two together. So you pull x out, you have a squared minus c squared, and you have x squared left. Again, those two get cancelled. You then have this one was combined with that, so you then have a squared y squared. Okay, so we are here now. You may pause your video here and figure out what I did right here, from here to here. Now, down here is that I said a squared minus c squared. A squared minus c squared is b squared. So I put b squared right here. And a squared minus c squared is b squared. So basically what we have here, right hand side is a squared, b squared. Left hand side is b squared times x squared plus a squared, y squared. So now I like to do is both sides divided by a squared, b squared, a squared, b squared. We know a squared minus c squared is b squared. So b squared cancel each other, a squared cancel each other. This gives us right hand side is just 1. Left hand side you have a squared cancel each other. So you have a y squared over b squared. Okay? And the b squared cancel each other. So you have x squared over a squared. So from here to here, you got a beautiful equation. Okay? Yeah, again, here we then have a squared equals b squared plus c squared. Or you may say is that b squared equals a squared minus c squared. B squared equals a squared minus c squared. Okay, now there is one thing I want to be clear, is that how are we going to find out this vertex? What is the coordinate for this one? No, we don't know. But, we can figure out that. Assume the coordinate here is from 0 to here, let's say, is a question mark. Okay? Is a question mark. From origin to this point is a question mark. So, remember, here was C, from origin to this point was C. So the question mark minus C is this distance from this point to here. Question mark is this long minus C. This was C, so will be this distance. Now, question mark, again, from origin to this point, this is question mark. From here to here is also C. Okay, is also C. But if you add the distance, this distance, with this distance, what do you get? What distance with what distance? Look. Let me put down here. So you see this pencil has a distance between this one and this one, which was question mark minus C, which is this part. There is a distance between the pencil and this focal point, which is question mark plus C. C is this part, from origin to here. Okay? So that's this part. Question mark plus C. Those two add together should be equal to 2a. Yeah. But you know, positive, negative cancel each other. So there you have a 2 times question mark equals 2a. So question mark has to be a. So what I meant was what? Was here this vertex should be negative a. 0. And this one is the same thing, should be what? Should be a0. Okay? So that's my note right here. The note right here says that the intersection between the ellipse and the major axis have a coordinates negative a0 and a0. That's basically called the vertices. Okay, that's the first remark right here. Okay. The second one is foci have a x have a coordinates negative c0, negative positive c0. That's that. Okay. And you know, here is another remark saying that the intersection between the minor axis and the ellipse here is b. So then what? Then you can mark this one is 0b. This one is 0 negative b. Okay, you can mark that. And remember the note here in the ellipse, a is always greater than b. Okay, is a always greater than b? A is the hypotenuse. For sure is greater than b, and a is also greater than c. Okay, those are the remarks. I will scan that and I'll put in the note. Okay, so you may print it out and then take a look. Okay, again, here is the center. Here is the center. And the terminology is for major axis. This will be the major axis, longer one. Shorter one is called minor axis. Okay, minor axis is the shorter one. And the center is right here. Another remark I like to do is this one. You see right here. Let me get another 2 pin. You put a pin here, and you put another pin here. Okay, and then you put a very tiny line on that. This is horizontal direction, and this is vertical direction. If you draw, if you draw a ellipse, what kind of shape you get? Not tight enough. Okay, you get this kind of thing. So in this case, well, the major axis is in this direction, okay, and then the minor axis is in this direction. The center is right here. So where is our A? A is always like that. Here is our A. Where is our B now? This is our B. And then C is from the center to here. C is always with A. And let's say how far is from the center to this vertex. From here to here is also A. From here to here. Okay, so A appears in two different places. Keep in your mind hypotenuse and from the center to this vertex. And B is shorter than A. Okay, from here to here is B, or from here to here is B. C is from here to the focal point. Again, C appears in two places. Horizontal direction, ellipse like this, and then vertical direction, the focal points are like this. Okay, remember the standard equation. Later on we'll use this. Okay, so I'll see you next time with examples.